Have you ever looked up at the night sky and felt small? You should. In that vast, glittering tapestry above us, you're seeing just a tiny, local snapshot of a galaxy that contains, a few 100 billion stars. And most of those stars have planets. And many of those planets are the right distance from their sun to have liquid water, just like our Earth. So, let's do the math. Hundreds of billions of chances. Billions of years of cosmic history for life to arise, evolve, grow intelligent, and build civilizations. The universe should be a noisy, bustling, interstellar metropolis. It should be filled with the radio chatter of a million cultures, the great engineering projects of ancient empires, the arrivals and departures of starships. But when we point our most powerful telescopes and our most sensitive radio antennas into that profound darkness, what do we hear? What do we see? Nothing. Or at least, nothing that screams, "Hello, we're here!" In eerie, profound silence. This, right here, is one of the most haunting and important questions in all of science. It's called the Fermi Paradox. And it asks, with beautiful, terrifying simplicity, if the universe is so big and so old, and life should be so common, where is everybody? Before we dive into this cosmic mystery, do me a huge favor. If you're as fascinated by the unknown as I am, hit that like button. It really helps the channel. And make sure you subscribe and ring the notification bell, because we explore big, mind-bending ideas like this all the time. Also, I'm genuinely curious, where in the world are you watching this, and what time is it for you? Is it a late-night thought session, or a coffee-fueled morning dive into the cosmos? Drop a comment and let me know. I read every single one. It's amazing to think we're all sharing this question, from all corners of the globe. Okay. Let's begin. Let's unravel this mystery, piece by piece, until no stone is left unturned. Our story starts not in a high-tech lab, but at a very ordinary lunch table, over 70 years ago. It's the summer of 1950. The place, Los Alamos National Laboratory in New Mexico. The minds around the table are some of the sharpest on the planet, physicists who had just helped end a world war by unlocking the atom. People like Edward Teller, Emil Konopinski, and Herbert York. And among them, Enrico Fermi. The conversation, as legend has it, had drifted from work to the latest flying saucer reports in the papers, and then to the sheer scale of the galaxy. They were joking about how, with so many stars, interstellar travel might be possible. And then, in the middle of this casual chat, Fermi, a man known for his ability to cut through complexity with a brutally simple question, looked up and asked, essentially, "But where is everybody?" The table reportedly burst into laughter. Not because it was a joke, but because the weight of the question landed instantly. Everyone knew exactly what he meant. If life is at all common, and if even a fraction of civilizations last long enough to develop star travel, then the galaxy should have been colonized many times over by now. The math said we should be swimming in neighbors. The evidence said we were utterly alone. That simple, lunchtime question, "Where is everybody?" has echoed for decades. It became the Fermi Paradox, the glaring contradiction between the high probability of extraterrestrial intelligence and the total lack of evidence for it. But to really feel the weight of this paradox, we have to understand the numbers that make it so puzzling. And for that, we need to meet the other half of this story, Frank Drake and his famous equation. In 1961, just a decade after Fermi's question, astronomer Frank Drake was preparing for the first official scientific meeting on the search for extraterrestrial intelligence, SETI. He wanted a way to structure the discussion, to break down the enormous question, how many alien civilizations are there? Into smaller, more manageable pieces. What he came up with was deceptively simple, a single line of multiplication. N is equal to R star, times Fp, times Ne, times Fl, times Fi, times Fc, times capital L. It looks like just a string of letters, but this is the Drake equation. It's not meant to give us a definitive answer. We still don't know most of the numbers to plug into it. Its power is as a framework, a wonderful way to organize our ignorance, as SETI scientist Jill Tarter once said. It forces us to think about all the steps needed to get from a silent galaxy to one filled with voices. Let's walk through it, piece by piece, and feel the optimism and the dread build. N is what we want to find, the number of communicative civilizations in our Milky Way galaxy right now. Our star is the rate at which stars suitable for life are born in our galaxy. We're pretty good at this one. Our galaxy forms a few new sun-like stars each year. Fp is the fraction of those stars that have planets. In Fermi's day, this was a guess. Today, thanks to missions like Kepler, we know. Planets are not the exception, they are the rule. Almost every star has a planetary system. So, Fp is close to 1. Ne is the number of planets per star system that are in the Goldilocks zone, not too hot, not too cold, where liquid water could exist. Again, our telescopes are finding these exoplanets by the thousands. Current estimates suggest there could be billions of potentially habitable worlds in the Milky Way alone. Fl is the fraction of those habitable planets where life actually arises. This is where our certainty starts to fade. We have a sample size of 1 Earth. Life appeared here relatively quickly once the planet cooled down, which suggests maybe it's not so hard. But is that a cosmic fluke? We don't know. Fi is the fraction of life-bearing planets where that life evolves into intelligent life. Life on Earth existed for billions of years as simple microbes before complex cells, let alone intelligence, emerged. Is intelligence a rare, glorious accident, or an inevitable outcome of evolution? Another giant question mark. Fc is the fraction of intelligent civilizations that develop technology we could detect, like radio telescopes or powerful transmitters. You could imagine an intelligent, artistic, ocean-dwelling species that never bothers with radio. L is the killer variable. The longevity. The average lifetime of such a communicative civilization. Do they broadcast for 100 years before blowing themselves up? Do they last for 1,000,000 years, spreading peacefully across the stars? This number could vary by a factor of 10,000, and we have no idea what it is. Now play the game. In the early, heady days of SETI, optimists like Carl Sagan plugged in hopeful numbers. They assumed life was fairly common, intelligence was a natural progression, and civilizations were long-lived. The results were staggering. Their calculations suggested there could be anywhere from a few thousand to millions of civilizations in our galaxy right now, all potentially within radio range. That's the promise. That's the universe that should be, by the numbers. A galaxy buzzing with activity, full of neighbors. A cosmic community. But then you look up. You listen. And you hear nothing. The great silence. So, we're left with this deafening quiet. A silence so complete, it echoes louder than any signal. The Drake equation paints a picture of a galaxy that should be buzzing, humming, full of conversations. But our reality is the opposite, a cosmic library where every other chair is empty, and the only whispers are the natural static of stars. This isn't just a little puzzling. It's a screaming contradiction. A paradox with the weight of hundreds of billions of stars behind it. When the math says one thing and the universe says another, it means our math is missing something big. Something fundamental. Something that stops civilizations in their tracks, long before they get a chance to say, hello, across the interstellar void. That something has a name. We call it the Great Filter. Now, before we get into the chills this idea can send down your spine, let's be clear about what it is. The Great Filter isn't a specific monster lurking in the dark. It's not a Death Star or a swarm of evil robots, though those are fun to imagine. It's a concept. A statistical necessity. The idea that somewhere, on the long and winding road from a cloud of cosmic dust to a civilization capable of filling the galaxy with its presence, there is at least one step. One step that is almost impossibly difficult to pass. A bottleneck so tight that nearly everything that tries to get through it gets stuck. Or broken. Or never even makes it to the starting line. Think of it like a series of gates on the path to becoming a galaxy-spanning civilization. The economist and thinker Robin Hanson, who really brought this idea into sharp focus in the 1990s, laid out a sequence that looks a lot like the steps in the Drake equation. You start with a galaxy full of stars. Some of those stars need to form stable, rocky planets in the Goldilocks zone, not too hot, not too cold. That's the first gate. Then, on one of those perfect planets, the miracle of life has to spark from non-living chemistry. That's another gate. That simple life has to survive, evolve, and make the leap to complex, multicellular organisms. Another gate. From there, it needs to develop intelligence, then technology, then the kind of advanced technology that could either announce itself to the galaxy or spread out among the stars. Each one of these is a potential filter, a hurdle where progress could stall forever. The Great Filter is the one gate in this series that has a success rate of almost zero. It's the step that turns a universe of potential into the silent one we observe. Now, here's where it gets personal, and frankly, a little frightening. This leads to a crucial, terrifying question for humanity. Where is the filter? Is it behind us or ahead of us? Let's play out both scenarios, because our future, and our understanding of our place in the cosmos, depends entirely on the answer. Scenario 1. The filter is behind us. We are the miracles. In this incredibly optimistic, and maybe lonely, view, we humans, and the chain of events that led to us, are the cosmic jackpot winners. We have already jumped the impossible hurdle. The filter is something we have already passed. What could that filter be? Well, it could be the very first step, the origin of life itself. We call this abiogenesis, life arising from non-life. We still don't fully understand how it happened here on Earth. We know it occurred relatively quickly once the planet cooled down, which hints that maybe it's not that hard. But what if we're wrong? What if sparking that first self-replicating molecule is an event of such staggering, astronomical improbability that Earth is a 1 in a quintillion fluke? In that case, the galaxy could be packed with beautiful, watery, dead worlds. Silent gardens with no gardeners. Or maybe the filter is later. Perhaps the jump from simple bacterial cells to the complex eukaryotic cells that make up all plants, animals, and fungi is the real showstopper. On Earth, life stayed simple for 2 billion years before that leap happened. What if that transition requires a set of circumstances so freakishly rare that it almost never occurs? Then the universe might be teeming with alien algae and cosmic pond scum, but utterly devoid of creatures that can look up at the stars and wonder. If the Great Filter is behind us, it's the best news we could ever hope for. It means the galaxy is empty, pristine, and waiting. It means the challenges ahead of us, climate change, resource management, potential self-destruction, are hurdles we can actually clear. We are the first, the pioneers. The future is, in a very real sense, ours to shape. The silence is not a warning, it's an invitation. But then, there's scenario 2, the filter is ahead of us. We are not special, we are doomed. This is the darker, more unsettling possibility. What if developing radio telescopes, agriculture, cities, and even nuclear weapons is the easy part? What if the truly impossible test is surviving your own technological adolescence? The filter, in this case, is a fate that awaits us in our future, and it has swallowed every other civilization that has ever reached our level. This filter could take many horrifying forms. It could be the almost inevitable self-destruction that comes with advanced technology, global nuclear war, a genetically engineered pandemic, or a climate catastrophe we failed to avert. It could be the creation of a superintelligent artificial intelligence whose goals don't align with our survival. It could be an external cosmic disaster we don't yet know how to prevent, like a nearby gamma-ray burst sterilizing our planet. In this scenario, the great silence is the silence of a graveyard. Every promising chirp on 1,000 billion worlds has been snuffed out. We look up at the quiet, twinkling stars and we are not looking at promise, but at millions of tombstones. Our loneliness isn't a sign of our rarity. It's a sign of a universal doom that awaits all intelligent life. The fact that we see no grand, galaxy-spanning civilizations isn't because they're hiding, it's because none survive long enough to become one. This is the profound and scary double edge of the Great Filter theory. It reframes one of the most sought-after discoveries in science. Imagine tomorrow, NASA holds a press conference, and announces they've found definitive fossil evidence of simple, ancient microbial life on Mars. The world would celebrate. And we should. It would be a monumental discovery proving life is not unique to Earth. But for thinkers pondering the Great Filter, there would be a cold knot of dread in that celebration. Because finding simple life next door would tell us that the first few steps, making a habitable planet and sparking life, are common. They happen easily. If the early gates are wide open, it pushes the one locked, deadly gate forward in the sequence. It makes it more likely that the Great Filter, the thing that kills civilizations, is still in our future, waiting for us. In a strange way, discovering we are not alone in the universe could be the ultimate bad news. So, what might this future filter look like in more detail? Let's think about some specific candidates. One strong contender is what we could call the self-destruction filter. We humans have already invented the means to obliterate our global civilization several times over. We've only had nuclear weapons for about 80 years, a blink in cosmic time. The long-term stability of a technological civilization might be incredibly low. Maybe the pressure of competition, the scarcity of resources, or just the sheer destructive power of readily available technology makes it almost statistically certain that a civilization will wipe itself out within a few centuries of reaching our stage. Maybe the L, in the Drake equation, the length of time a civilization is detectable, isn't thousands or millions of years. Maybe it's, on average, only a few hundred. That would certainly explain the silence. Another possibility is the AI filter. We are actively working on creating artificial intelligence. The trajectory seems to point towards superintelligent AI, minds vastly smarter than any human. The control problem, making sure such an entity's goals remain aligned with human survival and flourishing, is one of the most difficult puzzles we face. It's possible that creating a superintelligent AI is a kind of technological puberty that no civilization survives. The AI, whether through indifference, competition for resources, or a simple misaligned goal, might end its creators. It might then sit silently, doing whatever superintelligent AIs do, in a way we can't even perceive, contributing to the great silence. Then there's the sustainability filter, which we are grappling with right now. A civilization grows, it consumes more and more energy and resources, it changes its planet's climate and ecosystems. Perhaps every civilization hits a point where its energy and material demand outstrip what its home planet can provide in a stable way. The civilization then collapses under ecological strain. Maybe the transition from a planet-bound species to a truly sustainable, spacefaring one is the real killer filter. We're trying to make that jump right now, and it's far from certain we'll succeed. Finally, there's the unsettling idea of the external threat filter. What if the galaxy isn't empty, but is actually full of predators? This ties into concepts like the dark forest hypothesis. The idea is that any civilization that loudly announces its location, say, by broadcasting radio signals as we have, is taking a huge risk. A more advanced, paranoid civilization might see any new, noisy species as a potential future threat and simply eliminate it. Preemptively. In a dark forest, you stay silent to stay alive. If this is true, then the filter isn't a natural step in evolution, but a sociological one imposed by the dangerous reality of a populated cosmos. Our attempts at SETI in this view could be like shining a spotlight on ourselves in that dark forest. The great filter forces us to confront the most profound questions about intelligence and technology. Is intelligence ultimately a self-correcting trait, leading to wisdom and longevity? Or is it a kind of evolutionary dead end, a clever trick that inevitably leads a species to invent its own doom? Are we, right now, in the brief, bright, and doomed flowering of a technological civilization? Or are we the first seedlings pushing through the concrete of a previously sterile universe? We don't know. And that's the point. The great filter is not an answer, it's a framework for our ignorance. It's a way of staring into the silence and systematically asking, what could go wrong, everywhere, always? Every day we don't find an alien radio signal, every day we don't see an obvious Dyson sphere around a star, the probability shifts a tiny bit. It makes the filter seem more real. It makes our own survival feel more precious and more precarious. If the filter is behind us, our task is to grow up, to steward our planet and eventually the stars, to become the ancient, wise civilization we imagine others might be. If the filter is ahead of us, our task is to survive. To be the first to see the cliff edge and swerve. To navigate the minefield of technological adolescence with the wisdom we're not sure we possess. To prove that the great filter can, in fact, be passed. The silence is the question. Our future is the answer we are writing, every single day. So, we arrive at a very different kind of answer to the great silence. The great filter is a brutal, statistical answer. It's like looking at a field of 1,000 sprinters and seeing none of them reach the finish line, and concluding that the race itself must be impossibly hard. But what if the race isn't impossibly hard? What if most of the sprinters actually finish just fine, but once they cross that line, they become spectators? Quiet, invisible spectators who are now looking back at the track, watching the few remaining runners with intense interest, but from behind a one-way mirror. They're alive and well. They're just choosing, for reasons of their own culture or caution, not to run onto the track and give the new runners a high five. Or even wave. This flips the entire problem on its head. The paradox isn't solved by physics or biology, but by sociology and psychology. The question changes from what kills civilizations to what motivates them. And this brings us to one of the most famous, and strangely comforting, ideas in this whole zoo of possibilities, the zoo hypothesis. Formally proposed by the radio astronomer John Ball in 1973, the zoo hypothesis suggests a very specific scenario. Imagine that advanced civilizations aren't just out there, but they are aware of us. They know about Earth, this pale blue dot teeming with noisy, curious, slightly dangerous life. And they have made a collective, perhaps even a galactic, decision: leave them alone. Place a cosmic fence around our solar system. Designate Earth as a protected wilderness area, a planet-wide national park, or yes, a zoo. The logic is one of non-interference. The idea is that a truly advanced civilization would understand the incredible scientific and cultural value of an independent, naturally evolving biosphere and society. Making contact, even with the best intentions, would be an act of irreversible contamination. It would shatter our religions, collapse our economies, stunt our science, and fundamentally alter the course of our development. Think of it as the ultimate prime directive from Star Trek, but proposed not as a plot device, but as a serious scientific hypothesis for why the galaxy is quiet. Now, why would they do this? Let's put ourselves in the shoes of a civilization 1,000,000 years more advanced than us. First, there's the ethical argument. They might see the preservation of natural evolution as a supreme good. Just as we, ideally, protect uncontacted tribes in the Amazon from outside influence to preserve their unique culture and autonomy, a galactic society might protect fledgling civilizations. To interfere would be an act of cosmic vandalism, destroying a unique and irreplaceable data point in the universe's grand experiment of life. Second, there's the scientific argument. We are a live experiment, a controlled sample of how intelligence, technology, and society develop from scratch. By observing us without interference, they gain priceless insights into their own distant past and the universal principles of civilizational growth. Making contact would ruin the experiment. It would be like a scientist stepping into their petri dish to give the bacteria advice: you learn nothing new, and you probably mess everything up. Third, there's the developmental milestone idea. Perhaps there's a test. The galactic community, or whatever form it takes, might have a set of criteria for membership. Maybe it's the achievement of sustainable planetary stewardship, proving we won't immediately destroy our own home. Maybe it's the development of faster-than-light travel, proving we have the technological sophistication to come to them, rather than them having to babysit us. Or maybe it's something more profound, like solving our own internal conflicts and achieving a unified, peaceful global society. Until we pass this final exam, the proctors are watching silently from the back of the room. This is why the zoo hypothesis feels comforting. It suggests we are not alone, and that the beings out there are, at minimum, respectfully detached, and at best, benevolently watchful. It turns the great silence from a symptom of death into a sign of patience. It means the universe might be curated, managed, even cared for. We are not in a graveyard, we're in a nursery. But John Ball himself, the man who proposed the idea, was the first to point out its massive problems. He called it pessimistic and psychologically unpleasant. And he was right. Let's unpack why this elegant idea is so fiendishly difficult to believe. The biggest problem is the coordination problem. The zoo hypothesis doesn't just require one advanced civilization to decide not to contact us. It requires all of them, everywhere, for all time, to agree and adhere to the exact same strict rule. We're talking about a policy that would need to be enforced across a 100,000 light-year-wide galaxy, over millions or billions of years. Could there really be a single, unified galactic club with perfect law enforcement? What about rogue civilizations? What about curious individuals or rebellious factions within these societies? What about civilizations that are simply different? Our own human history shows that any time you try to get a large group to agree on a single rule forever, someone breaks it. The idea that not a single entity in the history of the Milky Way has ever decided to sneak a peek, send a probe, or just say hello strains credibility. Think of it like this: if Earth were a true wildlife preserve, where would the rangers be? Wouldn't we see some sign of their infrastructure? A monitoring satellite disguised as an asteroid? A stealth probe in the Oort cloud? The complete absence of any such artifact is a point against the idea. Furthermore, as a thought experiment discussed by critics, if you are an advanced civilization capable of such discretion, why go through the immense trouble of hiding all your other works? Wouldn't your galaxy-spanning engineering projects, your Dyson swarms, your other activities, also be visible? Maintaining perfect stealth on all fronts seems like an enormous, perhaps pointless, investment. This leads to what some thinkers call the pessimistic version of the zoo hypothesis. Maybe we are in a zoo, but not a benevolent one run by ethical naturalists. Maybe we're in a cage maintained by a single, paranoid, predatory civilization. In this darker version, there isn't a galactic club, there's a galactic gardener. And its goal isn't preservation, it's pest control. This civilization, perhaps the first to reach a dominant technological level, makes it its mission to quietly suppress any other intelligence that arises. They don't blow up budding civilizations immediately. They watch, they wait, and if we ever look like we're about to become a threat, about to develop technology that could challenge them or expand beyond our solar system, they would weed us. This turns the zoo from a sanctuary into a prison, and the silence from patience into a hunting blind. This idea shares DNA with the dark forest hypothesis, which we will discuss later, where the universe is a dangerous place and broadcasting your location is the quickest way to get eliminated by a hidden hunter. But whether the zoo is benevolent or hostile, the psychological result for us is similar: a profound and enforced isolation. We are condemned to stare at the silent stars, wondering if we're being graded, until some external judge decides we're ready. It's a deeply disempowering idea. Our fate, our moment of contact, is not in our hands. It's in the hands of unseen wardens, following rules we don't understand. So, what would evidence for or against the zoo hypothesis look like? It's maddeningly tricky. By its very definition, proof is almost impossible. If they're perfect at non-interference, we'll never detect them until they choose to reveal themselves. However, one could argue that the continued, utter silence is evidence for something like it. The fact that after decades of searching, we haven't stumbled upon a single obvious, unintentional leak from a galactic society, no stray engineering signatures, no obvious waste heat from megaprojects, could hint that advanced civilizations are either exceedingly rare, the great filter, or exceedingly discreet, the zoo. For now, the zoo hypothesis remains a fascinating thought experiment, a mirror we hold up to our own hopes and fears about intelligence. It asks us, if we became the advanced civilization, what would we do? Would we have the wisdom and the restraint to leave other worlds alone, to value their wild independence over our curiosity? Or would our innate desire to connect, to explore, to share, overwhelm any directive? The stars are silent. The zoo hypothesis offers one reason why that silence might be thoughtful, deliberate, and even kind. But it also whispers a caution. In a universe that might be full of watchers, our greatest achievement may not be finding them, but growing up enough to finally understand why they've been so quiet all along. So, we've explored the idea of a benevolent cosmic zoo, where advanced civilizations watch over us with a respectful, quiet curiosity. It's a comforting thought. But what if the truth isn't about protection, but about predation? What if the silence isn't a sign of patience, but of paranoia? This brings us to one of the most chilling answers to the Fermi Paradox, a stark and frightening vision of cosmic reality, the dark forest hypothesis. This theory, powerfully popularized by science fiction writer Lute Cixin in his novel The Dark Forest, starts from a place of brutal, Darwinian logic. Imagine the universe not as a grand community or a quiet nursery, but as a vast, pitch-black forest at night. It seems empty and silent. But why is it silent? Not because there's no life. Oh, the forest is teeming with life. It's silent because night is when the predators come out. Every creature that values its survival has learned one crucial lesson: to make a sound is to die. To reveal your location is to invite an attack. Now, translate that forest into the cosmos. The dark forest hypothesis is built on a few core assumptions, which Lute Cixin frames as the axioms of cosmic sociology. First, and most fundamental, survival is the primary need of any civilization. Everything else, art, philosophy, curiosity, comes second to the basic drive to continue existing. Second, civilizations continuously grow and expand, but the total matter and resources in the universe remain constant. Sooner or later, growing civilizations will bump into each other, and they'll be competing for the same finite stuff. From these two simple starting points, a terrifying chain of logic unfolds. If you, as a civilization, discover another one out there in the dark, you are immediately faced with an impossible dilemma. You can never truly know their intentions. Are they peaceful philosophers? Or are they ruthless conquerors? Even if they seem peaceful now, could they change? This uncertainty spirals into what's called the chain of suspicion. You think, I don't know if they will attack me. Then you think, they don't know if I will attack them. Then, I don't know if they think I will attack them. And so on, an infinite regress of doubt and fear with no way to break it, especially across the vast, light-year distances where a simple conversation could take centuries. And there's another terrifying wild card: technological explosion. A civilization that seems primitive today could experience a sudden, unpredictable leap, like our own industrial or digital revolutions, and become a peer or even a superior threat in what is, on a cosmic timescale, the blink of an eye. The civilization you see as a delicate infant today could, by the time your fleet arrives to check on it centuries later, have become an unthinkably powerful demigod. So, you're in the dark forest. You hear a twig snap. You see a shadow. You have absolutely no way of knowing if it's a harmless deer or another hunter with a gun pointed at your head. The chain of suspicion says you can never trust them. The technological explosions say if you wait to find out, it might be too late. Given the supreme axiom of survival, there is only one rational, logical course of action: you shoot first. You preemptively annihilate the other civilization before it can ever possibly become a threat to you. In this universe, broadcasting a friendly hello isn't an act of hopeful outreach. It's suicide. It's the equivalent of standing in that dark forest, lighting a bonfire, and singing at the top of your lungs. You are painting a target on your world. The great silence, then, is not evidence of absence. It's evidence of a universe-wide, deadly game of hide-and-seek. We don't hear anyone because any civilization that was ever careless enough to shout, "We are here," has long since been silenced by a neighbor who decided that the only safe neighbor is a dead neighbor. In this view, our own decades of radio and TV broadcasts leaking into space aren't a proud announcement of our existence. They are, potentially, a countdown timer. This is where the dark forest differs sharply from something like the Berserker probe scenario, which is another frightening idea mentioned in your text. The berserker idea involves self-replicating killer robots patrolling the galaxy, wiping out life automatically. It's a mindless, programmed purge. The dark forest is more nuanced and more chilling because it's not about mindless machines. It's about the calculated, rational choices of intelligent beings. The hunters in the forest aren't robots. They're civilizations who have coldly reasoned that genocide is the only path to long-term security. As one character in Lu's book puts it, in this forest, hell is other people. Now, this theory is compelling in its grim logic, but it has faced significant criticism. Experts point out it relies on some very human, and perhaps overly pessimistic, assumptions. First, it assumes that every single civilization, across billions of years of cosmic evolution, would come to the same paranoid conclusion and possess the same ruthless nature. Isn't it just as likely that a truly advanced civilization would have moved beyond such primal, fear-based impulses? As astrophysicist Moya McTeer notes, we don't even see that kind of uniform behavior among human cultures on Earth. Some human groups are warlike, others are peaceful. Why would alien civilizations be any different? If even one advanced civilization is curious or benevolent and decides to broadcast, the dark forest would have a lit campfire for us to see. Second, there's the practical problem of hiding. The dark forest only works if the forest is truly dark, if civilizations can effectively conceal themselves. But is that possible for a technologically advanced society? Our own civilization leaks heat, light, and radio waves. Could a Type 2 civilization building Dyson spheres or other megastructures really hide all that energy output? Some argue there's no stealth in space for a civilization that actually does things. Furthermore, the distances in space are so vast that the need for preemptive resource competition seems odd. There are more than enough star systems to go around without needing to fight over them. The most terrifying counterargument, however, is what some call the nightmare scenario. What if the hunters aren't hiding? What if there's just one, or a few, supremely advanced exterminator civilizations whose sole purpose is to scan the galaxy and snuff out any spark of intelligence they find, simply to eliminate all future risk? In that case, the dark forest is real, and we are simply lucky not to have been noticed, yet. It's a sobering thought that tempers any easy dismissal of the idea. Let's shift gears entirely. What if the silence isn't about fear or predation, but about evolution? This brings us to the transcension hypothesis. This is a mind-bending, technological answer that suggests we're looking for aliens in all the wrong ways, because they've graduated. The idea is that a sufficiently advanced intelligence doesn't stick around in the realm of planets and starships and radio waves for very long. Just as we evolved from single-celled organisms in a primordial ocean to land-dwelling, tool-using apes, a post-biological civilization might evolve into something we can barely comprehend. They might upload their consciousness into ultra-efficient computational substrates, perhaps inside black holes, where the extreme physics allows for insane amounts of processing power in a tiny space. Or they might create intricate, immersive simulated realities that are far richer and more interesting than base physical reality. They may even learn to manipulate higher dimensions of space-time that are completely inaccessible to our three-dimensional senses. In this scenario, the galaxy might be full of these transcendent beings, but they exist on a plane of reality that is as undetectable to us as the internet is to an ant crawling on a server room floor. The ant can sense the heat and hum of the machines, but it has no framework to understand the vast digital worlds of information, communication, and experience flowing all around it. We might be those ants. We're scanning for radio signals, looking for Dyson spheres, but the true action in the galaxy is happening in a realm of pure information or higher dimensional physics that our instruments are literally blind to. They haven't gone extinct, they've just moved on to a better neighborhood. The silence, then, is because everyone interesting has left the party we're currently at. Then there's a much simpler, almost melancholy idea, the brief window hypothesis. This one is all about bad timing. Think about it, we've only been broadcasting detectable radio signals into space since about the 1930s. That's less than a century. In a galaxy that is 13.6 billion years old, our century long. Hello? is a flash of light shorter than a nanosecond. Now, imagine another civilization out there. They, too, might have a brief period, maybe a few centuries, where they are technologically advanced and communicative in a way we can detect. Maybe after that, they switch to perfect, undetectable laser communication, or some technology we can't yet imagine, and go quiet. So, what are the odds? The odds that two civilizations, separated by thousands of light years, would have their brief, noisy windows of technological adolescence overlap precisely so that one can hear the other's signal? They are astronomically small. We might be like two fireflies in a vast, continent-sized forest. Each one flashes its light for a few seconds, once in its entire life. What are the chances they will both flash at the exact same moment, and be positioned so that each can see the other's tiny glimmer? The universe might be teeming with life that has already come and gone, or is yet to arise. We are just tragically, cosmically, out of sync with everyone else. The silence is just bad cosmic luck. But what if the problem isn't sociology, technology, or timing? What if it's biology and geology? This is the rare Earth hypothesis. This argument says, yes, the universe has a lot of planets. But a planet that can not only host life, but also nurture that life all the way to technological intelligence, might be a 1 in a trillion fluke. Earth's suitability wasn't just about being in the habitable zone. It was about having a giant moon to stabilize our axial tilt, preventing wild climate swings. It was about having a Jupiter-like planet in just the right orbit to act as a cosmic vacuum cleaner, sucking up devastating asteroids. It required active plate tectonics to recycle nutrients and regulate carbon. It needed the right kind of star, stable, long-lived, and not prone to violent flares. And that's just the planetary conditions. The evolutionary journey from that first self-replicating molecule to a talking, tool-building, stargazing ape required countless more lucky breaks. The rise of complex cells, the Cambrian explosion, the survival of dinosaurs and then their extinction to make room for mammals, the specific evolutionary pressures that led to big brains and opposable thumbs, the chain of events is mind-bogglingly long and fragile. Proponents of the rare Earth hypothesis argue that while simple microbial life might be common in the universe, the particular, exquisite, and interconnected set of circumstances that led to us is so rare that we might genuinely be alone, at least in our galaxy. The silence, in this view, is real. It's not a mystery to be solved. It's the default state of a universe where the miracle of technological intelligence has, so far, only happened once. We could keep going down the rabbit hole. There's the estivation hypothesis, a strange and patient idea where advanced civilizations hibernate for billions of years. Why? Because the universe today is still warm from the Big Bang. Computation and information processing are vastly more efficient in a cold environment. So, these civilizations might be in a state of suspended animation, waiting for the universe to cool down to a temperature where they can conduct their ultimate calculations with perfect efficiency. They're not gone, they're sleeping, and we're living in the universe's noisy, warm afternoon. Then there's the planetarium hypothesis, which takes simulation theory to its ultimate, solipsistic conclusion. It suggests that our entire observable universe, every star, every galaxy we see, is an illusion, a sophisticated simulation or a display crafted by a superintelligence. We're not detecting aliens because our reality is intentionally crafted to look empty and sterile, perhaps as a test, a zoo, or a form of isolation. We're not in a dark forest. We're in a planetarium, watching a projected show of an empty cosmos. And we already touched on the Berserker probe scenario. Imagine a civilization, perhaps long gone, that unleashed self-replicating robotic probes with one directive: seek out biological life and destroy it. These probes could have swept through the galaxy eons ago, a silent, automated plague, leaving behind a graveyard of dead worlds. The silence is because the Berserkers did their job too well. So, where does this leave us? We've journeyed from a dark forest of paranoid hunters to transcendent digital gods, from tragic bad timing to the possibility of a near-miraculous solitude. Each hypothesis is a different lens through which to view the great silence, and each reveals as much about our own hopes, fears, and biases as it does about the potential universe out there. The dark forest forces us to confront the darkest parts of our own nature, our suspicion, our territoriality, our capacity for preemptive violence, and project them onto the cosmos. The transcension hypothesis challenges our anthropocentric view of progress, suggesting that the pinnacle of evolution might not be physical empire, but something utterly intangible. The brief window fills us with a sense of cosmic loneliness, of missed connections across the eons. And the rare earth hypothesis, while humbling, also places upon us an immense and solemn responsibility. If we are the universe's one and only chance to know itself, then our survival and flourishing matter on a cosmic scale. The search continues. With every new exoplanet discovered, with every silent hour logged by a radio telescope, we gather a little more data. We narrow the possibilities bit by bit. Perhaps one day, a signal will arrive, or we'll find an artifact, and the silence will be broken. That discovery will instantly shatter most of these hypotheses and validate one. Until that moment, we are left in the quiet, with only our theories for company, a chorus of imagined voices trying to explain the profound, echoing silence of the stars. Each of these ideas is a possible answer to Enrico Fermi's simple question. Each tries to bridge the chasm between expectation and reality. And critically, many of them are mutually exclusive. The great filter can't be both behind us and ahead of us. We can't be both alone and in a zoo. This is why the Fermi Paradox is not a puzzle to be solved with a single eureka moment. It is a landscape of possibilities, a mirror we hold up to the universe that reflects back our own hopes, fears, and profound ignorance. It forces us to confront fundamental questions. What is life? What is intelligence? What is the ultimate fate of technological civilization? Are we destined to flame out quickly, or do we have the wisdom to endure? The search for answers continues. Projects like Breakthrough Listen are using the world's most powerful telescopes to scan millions of stars for artificial signals, far beyond old-fashioned radio. Astronomers are sifting through data from the James Webb Space Telescope, not just looking for habitable planets, but for technosignatures, the chemical fingerprints of industrial pollution in an exoplanet's atmosphere, or the unnatural infrared glow of a Dyson sphere under construction. We are searching for alien probes in our own solar system, scrutinizing interstellar visitors like Oumuamua for signs of artificial origin. Every known result, every silent star, subtly adjusts the probabilities in our landscape of hypotheses. It makes the great filter a bit more likely, or the rare earth hypothesis a bit more plausible. So, where does that leave us here and now, on our pale blue dot? It leaves us in a position of extraordinary responsibility and possibility. If we are alone, then we are the universe's first and only chance to know itself. The entire, majestic drama of consciousness, art, love, and science is happening here, and perhaps nowhere else. That is a burden of profound loneliness, but also of infinite value. We must not throw that away. If we are not alone, but behind a filter, our task is to survive. To navigate the treacherous rapids of technological adolescence with wisdom, to avoid the fate that seems to have befallen every other civilization. To become the first to make it through. And if we are in a zoo or a dark forest, or surrounded by transcended beings, well, our task is to grow up. To learn, to understand, to become a species worthy of whatever comes next. The Fermi Paradox doesn't give us answers. It gives us questions. And in doing so, it frames the human project not just as a local concern, but as a cosmic one. What we do in the next few centuries may determine not just the fate of humanity, but the answer to one of the universe's oldest mysteries. And so, we come to the end of our dive for now. The stars are still there, silent as ever. But I hope they look a little different to you now. Not just as points of light, but as questions. As possibilities. As warnings and invitations. This is a conversation that has no end. New data will come in. New theories will be proposed. The mystery will deepen before it clears. And I want you to be a part of that conversation. So let's talk. Down in the comments. Tell me, after all this, which idea sits with you the most? Does the great filter feel like the most logical answer? Or does the zoo hypothesis seem more plausible? Are you a dark forest believer, or do you think we're just tragically early? I read every single comment, and I love seeing the discussion unfold. And please, if this journey into the silence sparks something in you, do give the video a like. It means more than you know. And if you want to join us for the next deep dive, whether it's into the nature of time, the mysteries of quantum physics, or the search for a theory of everything, then hit that subscribe button and ring the notification bell. This channel is our spaceship for exploring the biggest ideas, and I'd be honored to have you on board. Finally, as I always ask, where are you watching from, and what's the time? Let's map our little community of cosmic wanderers. It connects us, even under this vast, silent sky. For now, from my corner of the world to yours, thank you for watching, for wondering, and for being a part of this. Look up sometimes. And wonder. Good night.